is some terminology which you are probably somewhat familiar with, and that is the way the data is stored in memory. Okay? Most of you probably heard of these terms. Let's make sure we understand them. Okay? So if I talk about memory, let me draw it over here. If I talk about a memory location, and I brought my own nice markers, and if this is X, which has an address with it, how is X stored? How is X stored? What is it broken up into in the machine? It's broken up into bits. The smallest unit in the computer is what we call a bit. Smallest unit in the computer is what we call a bit. Now, a bit can have what value inside any one of these bits? What can the value be? Okay, why? Why 0 or 1? Tyler? Okay, so the computer is electronic, agreed? The computer is electronic, okay? So if I turn an electronic device off, we have two states. We have on and we have off, okay? So each bit in a machine has a 0 or 1 corresponding. 0 is off and 1 is on, okay? All right, so keep that in mind, all right? So all these bits are a combination of zeros and ones. Can you guys see over there? Probably not, okay? All right, now the second, a bit's not tremendously useful. It doesn't tell us much. So instead, we're interested in what we call a byte. And a byte is what? 8 bits. A byte is 8 bits. So this entire representation here is a byte, okay? 8 bits. And this is going to be more useful to us, all right? Now, one thing useful about a byte, and hold this thought, is that a character fits into a byte. What do I mean by a character? What do I mean by a character? Ideas? A letter? What else? Number, symbol. Okay, so hold that thought because we're going to talk about that too. Okay? Now, the next term we have is a word. Now, a word varies from computer to computer. How many people have heard of the term a 32-bit machine or a 64-bit machine? Okay? That essentially refers to the word size, or how much is addressed at a time. So obviously, a 64-bit machine should have higher capacity than a 32-bit. Does that make sense? Because we can store larger values in there. Now, does that mean that a 64-bit machine is twice as fast as a 32-bit machine? Not necessarily. It's sort of like if we take the Beltway and we go from 3 to 6 lanes, you're not going to get there in half the time. It will make things faster, but not every trip is going to be, right? It's going to increase things, but not double. Okay? All right. So that's what a word means. It's the number of bits that are handled by a particular machine. And that gets larger and larger as computers get more and more sophisticated. Make sense? With me? Okay. Everybody's heard of a kilobyte or a K. A K is exactly equal to 1,024 bytes, but we usually round. So if we look at a file and it's 16,432 bytes long, how big do we say that file is? 16K. We don't usually get our calculator out and divide by 1,024. We say it's approximately 16K. So a K is exactly 1,024 bytes, approximately 1,000 bytes. And you're probably familiar with these terms. A megabyte is 1,024 times 1,024, whatever that is, but we approximate that to be 1,000,000 bytes. And a gigabyte, 1 billion bytes. So these are just